we go. Okay, we're live. Common factors of a polynomial. Okay, I like to always start talking about factoring as to what factoring is. Factoring is an opposite operation. As you've learned math through your whole life, you've learned that as soon as you learn how to do an operation, you learn that there's always an undo for an operation. There's an opposite operation. When you learn to add, then right away they teach you how to subtract because they're opposites. The opposite of multiply is divide. The opposite of square is square root. So along came grade 8 and grade 9, and they taught you this wonderful thing called the distributive property. And you realize, oh, I have to times both things in the bracket by the thing outside the bracket, right? But did they ever mention that there's a way to undo that? The opposite of the distributive property is factoring. So basically, when I'm factoring a binomial, what I'm asking you to do is, I'm asking you, let's do some writing here, to find the GCF of the two terms. I'll just say of the terms, because sometimes there'll be more than two. And what is it? What's the biggest number I can take out of 6x and 9? The answer is 3. Okay. So I factor that out. And then I ask myself, I say, self, what goes in that bracket so that if I multiplied it, if I did the distributive property, I'd get this back again? And it's pretty, yeah, it's basically undoing distributive property. This has to be 2x plus 3. If you want to think of it like it's a divide both of those things by 3, that's good. But I got to admit, I'm not really thinking divide when I do this. I'm thinking more fill in the blank. What blank has to be in there to make that work? And then this expression would expand back into 6x plus 9 using distributive property. But this is what we call factored form. All right. Second one's a little tougher. What's the GCF in this one? Higher. It's not a higher number. Yeah, notice both of those terms have a d in them. Remember that d squared, you don't have to write this part down if you don't want to, is d times d, right? That would be the prime factorization of d squared. It's d times d. So they both have a d in them. So the GCF is actually 4d. Does the logic of that make sense to you? Do you see logically why there has to be another thing there? So I can take out a 4d, and then what goes in that bracket that would give me back 8d plus 12d squared? There's definitely a 2 here, and 3 times d here. And if you want to do just a quick check, you could multiply it out and see if you get the right thing. But I think we got it. I'm not going to bother with the check. How come the 2 doesn't have a d on it? Well, because if I times the d by a d, I'd get a d squared. I don't want a d squared. I want 8d. All right. So there we go. So that's one of them. Okay. What about this one? What's the GCF in this one? Yeah, this time I can take an x out of the first term. I can take an x out of the second term. Oh, but there's no x in the 5. So that's it. The greatest common factor is just 5. So it's going to be 5 and then x squared minus 2x. Now here's an important thing. I'm gonna change to a red pen on purpose. I'm making a mistake on purpose. Don't write this part down. Don't write the red. Done. Because when you factor 5 out of itself, it's gone. There's nothing left. Okay, now the person who would say that, I challenge them. I say, okay, multiply that out. See what you get. Well, you get 5x squared minus 10x. Oh, yeah. I don't get a plus 5. So that clearly is wrong. What actually belongs at the end of this statement? A plus 1. When you factor something, I'm going to put that in a note. That's an important idea that's so easy to forget. Remember that factoring a number out of itself leaves behind a 1. And I don't know why that happened. Those are quotation marks. There we go. And I say a number. Remember X, Y, Z, A, B, C. Those are numbers too. People go, they're not numbers, they're variables. Well, that's all a variable is, right? A variable is just a number. I don't know what it is. But it's still a number. Okay, so keep that in mind. Oh, and actually, you know what? We're going to put a star by this one. I'm going to put a big asterisk-y highlighted star. You know why? Because you're going to remind me when we do lesson 3.5 to come back to this, because I actually could factor that some more. I'm not going to show you that today. So we're going to come back. As of right now, that's as far as you can go with that question. So there we go. Now we're going to do this guy. All right. What do you notice? Well, once again, can I take z's out of a term that doesn't have a z? No. So the GCF, once again, is just 6. So take out a 6, and what do you think is left over? Well, there's definitely a 1. Minus 2 z's. And then, why do you think it's a minus? I think it's a plus. Plus 3z squared. And then I'm going to do that same asterisk thing again. Next lesson, you're going to learn that you could actually factor that some more. Yep. There you go. That's exactly what the next lesson is, yeah. So that's what's coming next. Somebody has already seen this stuff and says, hey, we can anti-foil example 3 and example 4 and get the binomials that make them. And yes, we're going to do that next lesson. Okay. For right now, we're just factoring by greatest common factor, which is always the first thing you look for. Now, this takes some thinking. What do they all have in common? Let's start with the numbers first. A 20, a 30, and a 25. Feel free to make a prime factorization statement if you want to. What are you thinking? They'll have c squared, but let's focus on, you're right, there's going to be a c squared. Here, I'll write it down. They all have a c squared. And they all have a 5. I agree with that. 5c squared. And can any of them give, one of them can give me a d squared. Can they all give me a d squared? No. 5c squared d is the greatest common factor. It's the most they can give me. How come I didn't stop at just 5cd? Well, because then there would be a common factor of c left behind in the 3 of them. The goal is to not leave any common factors behind. So that's that one. Okay, thank you. So I am going to take out 5. Come on, pen. 5. I put a new battery in it today. I think it's because at the end of the day, this thing gets hot and the heat makes this thing not recognize that I'm writing on it. That's what I think. That's my hypothesis anyway. Because early in the day, I don't have this problem. It's the computer. It's not the pen. I think this tablet gets goofy hot. That's what I think is going on. It's a Dell, I believe. There's your problem. Hey, I didn't pay for it. The division got me this nice thing so that I could teach the people at home easier, and I'm very grateful for it because for most of the day it works just fine. Okay, anyway, ask yourself, say self, what goes in that blank? Okay, yes, a 4 for sure. Very good. It has to be a c squared. Otherwise, I wouldn't get this 4 back. But do I need a d on that first term? No. It's got enough d's when you multiply it together. It's still a minus here. 6. I need another c, and I need another d, plus 5. And that's it, just plus 5. I guess I kind of put that bracket too far over. Yeah. There we go. I got good news for you. That's about as hard as the factoring gets for greatest common factor factoring. Okay? The next level of factoring is quite a bit harder because we have to, like one of your classmates said, we have to think about the opposite of foiling. Just like this is the opposite of distributive propertying. We'll get to that in a few minutes. But here's our last example for this for today, and then we're going to do a little activity that will be kind of fun. Okay, so you know what I noticed about these? I noticed that all 3 of them are negative. I don't have to factor out that negative, but I think I will, because it'll leave, I'm always thinking I want to leave the simplest thing I can in the bracket. So I'm going to factor out a negative, and that's the only hint I'm giving you. Okay, so think about it. Try it with your own pencil there. Always write in pencil, that way if you goof it up, you can just erase. All math should be done in pencil. Nobody, only psychopaths do math in pen. Einstein did math in pen. Everybody uses pencil in math. If you have an erasable pen, you can use those, but I hate those. I don't know how you can work with those. Erasable pen technology still has a long way to go. You write with the erasable pen, and then you accidentally drag your wrist over it, and it's all smeared. We're talking about erasable pens. We should be doing example 6, sorry. All right, so first let's do the number. 12, 20, and 16. What's the biggest thing you can take out of those? I agree, it's a 4. Now, what's the variables? They can this one can only give me an x, and this one can only give me a y. So that's it. Now, what's left behind when you factor a negative out of a negative? It's going to be a positive 3 and then an x squared. Does it need a y? No, because when I multiply, I only want one y. It's going to be a plus 5. I don't need any more x's, but I need one more y. And when I take negative 4 out of negative 16, I should have a plus 4, and I need one more x, and I need one more y. Hopefully everybody recognizes, too, that none of these 3 things are like terms. They all have x, y. Can't I add them together? No, because remember, they're only like terms if they have the same exact powers. Exponents, same thing. Okay, so that's really it. Today's lesson was kind of short. That's why I thought we'd do a little cute little activity, and then I'll give you some work time. Okay, the activity itself I'm not going to bother actually recording, so I'll shut the recording off for now. Okay, take out a piece of loose leaf.